Hello everyone, welcome to this session on working with delimited text data in QGIS. Till now we have seen the basics of remote sensing and GIS. Then we have seen the introduction to QGIS and how to install the software on our systems. And then we have seen a variety of open access geospatial data sources. Going further in this session, we will explore how text data, delimited text data can be used within QGIS to create, manage, and analyze spatial information. Often the real world data comes in text formats. If it is structured and can be saved as a delimited text data and has geographical coordinates, it can be transformed into spatial layers that can be visualized, analyzed, and combined with other geospatial data sets. So we will see how we will try to download a CSV file, a delimited text data file, and we'll try to convert it into a GIS layer, vector layer. And then we will also see, while doing this, we will also see some basic functionalities of QGIS as we have just begun to use the software. And some simple tips we will see. And then how can we perform attribute-based operations, some basic attribute-based operations that we will see in this session. Now let us see what is meant by delimited text data. Delimited text data refers to structured text data in which individual values in a row are separated by a specific character known as a delimiter. The commonly used delimiters are comma, tab, semicolon, and space. While using Microsoft Excel or spreadsheets, you may have seen many of the files with .csv extension that can be opened in Microsoft Excel. Those are actually text data where individual values in a row are separated by comma. Similarly, you may have come across TSV files with .tsv extension, that is tab separated values. Any structured tabular data can be easily stored as delimited text data. Commonly mostly like CSV files or TSV files. Each row in the delimited text file is termed as a record, whereas each column is termed as a field. In talking in terms of vector data, if you open a vector data attribute table, you have the columns which are known as fields, and individual rows are records which correspond to individual features. Feature in GIS is nothing but a real world object or a phenomena that can be represented on map. If you are talking of point vector data, their individual rows are individual point features. Similarly, if it is line vector data, individual lines, individual rows are like individual line features, etc. Now each feature will have a geometry and then attribute, or otherwise you can term it as spatial data as well as non-spatial data. So any delimited text data having spatial coordinates can be easily converted into a vector layer. We will see how we can do that. Now let us get some delimited text data and see whether we can convert it into a GIS vector layer. You can go to this portal data.gov.in where you will find lot of data in CSV format. You can check for the data sets. Now this is a real-time air quality index from various stations data which is available for download as a CSV file. You can check about this data set which is provided by CPCB, real-time air quality index from various locations, various stations, as collected from the field instruments. The data is displayed without any human intervention from CPCB. Now you can click here to download the data, specify your purpose, non-commercial, academia, and then give your name, email ID and mobile number, and type this code. click on this download button. That will download the CSV file onto your system. The file is downloaded. You can open it. Let me go to the folder, downloads folder. Yeah. So this is a CSV file. These are the column headers or fields. And you also have the latitude and longitude, that geometric coordinates are there. So you can convert it into a GIS vector layer. So you have the station name, where it is located, in which city, state and country, and then what is the pollutant that is being measured or monitored, and the value of the pollutant from that particular day, minimum value, maximum value and average value. There may be no data value because of the malfunctioning of the instrument or any issue with the transmission of the data. So you can see there are how many records are there. There are about 3,362 records from that particular day. And each station has variable number of monitoring parameters. Some are monitoring NO2, nitrogen dioxide, ammonia and ozone. Some are monitoring PM10, PM2.5 and then ozone also. So let us save this file with a proper name as a CSV file. Say air quality data from 2nd November 2025. So I have saved this file. Now let us launch QGIS. Once QGIS is launched, you can open a new project by going to project and then new. Now there are many ways of adding data to your QGIS. One way is by going to layer in the main menu and then add layer. You will have many options of adding vector layer, raster layer and also adding delimited text layer. And there are other layers that database layers and then point cloud layer, etc. Now we will be mostly working with the vector data and raster data, and now we are going to work with add a delimited text. We are going to work with delimited text. So you can click add delimited text layer. So then it will open this dialog box. You can arrive at the you can arrive at this step by following clicking this icon here. Now you can see in the toolbars, if you take your mouse, it will tell you the name of the toolbar, which is Data Source Manager toolbar, and this icon is Open Data Source Manager. If I click on this icon, it is it will open the same dialog box where you can go to this tab delimited text to add the layer. So first you have to browse your file where you have saved it by clicking these three dots and then going to the folder where you have saved your layer and select not layer, file, and then select it, then click on open. Now it has detected that it is a CSV or comma separated values file. In case if it is a TSV file or some other file with some other delimited text file with other delimiters, you can check this custom delimiters and you can specify the which is the delimiter, whether it is tab or semicolon or colon or space. Now in this case it is CSV file. Then you have to define the geometry. Now these, you see in the original CSV file you have the longitude and latitude. The geometric coordinates are stored in two fields named longitude and latitude. Now you can tell this to the software that your x field, along the x field, along x direction, longitude changes, whereas along y direction latitude changes. So we have to specify the column header having the values of longitude. In this case it is longitude itself, so x field is longitude, and you can see the various fields are the column headers from the CSV file, and the y field is latitude. And then you have to specify what is the geometry. Now you can see we will be coming to map projections afterwards, but when we are talking of geometry, here we are going to use the global coordinates of longitude and latitude. Then you have to go for GCS, that is global coordinate system, which is EPSG 4326, whereas this EPSG 32645 and other like 32643, these are all UTM are projected coordinate systems. UTM we will talk about this coordinate projected coordinate system afterwards. So here you have this 4326, EPSG 4326 is the code. Now how to find these codes? You have this website spatialreference.org, and also one more website epsg.io. Yeah, so you can search for any projected or coordinate reference system. Then you can find the EPSG code of that CRS. In our case it is GCS, that is EPSG 4326 WGS 84. If you are unable to find if you are working with some other CRS, and if you are unable to find, you can click this icon, select CRS, and search for the EPSG code number like 4326. So this is geographic coordinate system WGS 84 EPSG 4326. Okay, so you have defined the geometry, you have specified the x field and y field, and now come to this sample data. It is neatly structured. In case if you are have given any of this file format was given wrong, or some other error that you have made, then you won't find this in this fashion. So you have correctly you have given all the inputs of file format, geometry, x and y field, and geometry CRS. Now you can click on add, then close. Now you see in your map canvas area, these are all different points which have been added. You can sense that is you can see that it is in the shape of India. Now it is still a tabular text data. If you want to save it as a GIS vector data, you can do it by right clicking the layer name in the layers panel and go to export and click on save features as. and then in the format, save vector layer as. These are the different formats in which you can save your vector file. The most popular one is S3 shapefile, which is very old actually, and it has many limitations. You can save it as a geo package instead. What are the limitations of the shapefile? I think we have already talked about it, or we will be talking about it. Like shapefile, in a shapefile always comes with some associated files, and you have to keep them together. In case if you misplace any of those associated files with extension dbf cpg shx, and the main file is having extension shp, so it is all of them should be together in one folder, otherwise you won't be able to make use of that shapefile. Now each of these files contains different information, like .dbf has data base information, .prj will be having projection information. And also one more limitation of shapefile is that any shapefile will have either point layers or point features only, or line features only, or polygon features only. You will not be able to store point features as well as line features in one single shapefile. Whereas in geo package, which is a modern database based format, you can have different layers, point features, as then line features and polygon features together. You can save it in the geo package. Now let us save it as a shapefile for the time being. We will deal with geo package format. We'll also deal with it. Now I will save it in, for the time being I am saving it in downloads folder, but for you it is suggested to always create a folder by the name. Like, let me otherwise create one folder by the exercise data and give the date. Okay, and then you save it again with the same name, air quality data from 2nd November 2025. Then save. The CRS is 4326, and then you can click on OK. Now you see another layer is added to the layers panel. Now the layer which has been added is the vector data. Now you can remove the old data which is text data. Now to remove any layer from the layers panel, you can right click, select it first, and right click, and then click on remove layer. Okay. Now you can check the attribute table of this layer by clicking on open attribute table. So you can see the same, it has the same structure as the original CSV file, with the same column headers or field names, and then individual rows which are 3361 in number. You can check the file where it has been created, the shapefile. As we were saying, shapefile is always a group of files. The main file is .shp extension. In your case, you may not be finding all the associated files, but you will be finding dbf file where database attribute information is there, prj file where projection information is there. This GPKG is different, which we will create a geo package, but these are the shapefiles components. And to add any shapefile component, you have to add this .shp extension file. Now this is the layer, a new vector layer that we have created from the delimited text data. If you want to see the number of features, individual features, you can open the attribute table. We have seen that it has 3361 features. You can right click and click on this show feature count. So in parenthesis, it will show you the number of features in any vector layer. Now we will try to once you observe again the attribute table, I think for every station each parameter is given a separate record. Like if you click on any of the column header, columns are known as fields. So they will be you can sort them in ascending or descending order. One click ascending order and another click descending order. So this is a particular station, Jew Park, Hyderabad, located in the city of Hyderabad, state Telangana, country India. And this particular station is observing or measuring these many indicators, air pollution indicators, 6 or 7: ammonia, PM2.5, sulfur dioxide, carbon monoxide, PM10, nitrogen dioxide, ozone. 7 parameters. And each parameter minimum value, maximum value observed for the day, and then the average value. So every station has multiple records for every pollutant. So let us try to do some manipulation of attribute table and create new layers. What we can do is we can filter, right click the layer in the layers panel, click on filter, and these are the fields. Fields are column headers which are available. You can build your query, say pollutant. Double click in this, double click here, then your query or filter expression is, you can write it here. So a field is within double quotes. If you want to filter only say PM2.5 records, now instead of typing everything, what you can do is you can look for what are the values which are in this unique values which are in this field. Click on all. So these are the unique values which are in that particular column of pollutant name. So you can take it as PM2.5. What you can do is, for writing the filter expression, the field name is equal to operator is equal to, then click the value PM2.5 one time. So this is full expression, and then click on OK. So you see this symbol, filter symbol, it indicates that the layer has been filtered. And how many features are there? 490. So out of 3361 records, 490 records are pertaining to PM2.5 value of different stations all over India from that particular date. Now if I right click and click on open attribute table, you will find only the filtered records. So only pollutant 2.5, PM2.5 records are there. Now suppose if you want to create a separate layer of PM2.5 records, one way is you can select all these filtered records by clicking this button, select all. Selection in attribute table is always highlighted in blue. Correspondingly, you will find the highlighted points or features. If it is a line, vector line of line features, lines will be highlighted. If it is polygon, polygons will be highlighted. So these points are highlighted in yellow. Both are linked. And then after selection, you can right click, go to export, and click this second option of save selected features as. If you click you should not click save features, but only selected features. Save selected features as, and now you want to save these particular features of PM 2.5 as, say we are talking about geo package. So let us save them instead of shapefile. Geo package, the advantage we will see how it is better format for saving geospatial data. So format, you can give it as geo package, and you can name the file as, same name you can give, air quality data 2025. Now the extension will be GPKG, geo package extension. Then give the path, and you can give the layer name as simply PM 2.5, which is understandable or can be easily recognized. So you can have a stack of layers within one geo package file. Different layers can be put in as a stack. It is actually a database based format. And then CRS is EPSG 4326, which is global coordinate system, WGS 84 datum. It is not projected. We have the coordinates in longitude and latitude, geographic coordinates, and then click on OK. So you see a new layer has been created. There will not be much difference between these two because stations are same. Almost roughly about 500 stations are there which are measuring these parameters. PM 2.5, maybe 490 stations are measuring, as in this case. Other parameters are measured by different number of stations. Maybe some stations are not measuring all the 7 parameters, or we don't have the data from that date. So you can again, if you check or uncheck any layer, it will be visualized, it will be displayed. Suppose you want to check the information pertaining to any particular feature. You can zoom in. You can make use of this tool, identify features, which is inside attributes toolbar. I symbol, click on I symbol, select the layer, and then click on any particular feature. Here it is point. It will give you all the attribute data information, all the records in the row, whatever information is there. The ID is 38, country India, and the values, longitude, latitude, and pollutant values. In this manner you can get information about any particular feature. The same tool can be used to get pixel values when you are dealing with raster data. And suppose you want to go back to the full extent again, now this I symbol indicates that this tool is still active. You can go back to hand symbol, click on hand symbol, and then you can right click this layer and click on this zoom to layer. Then it will show you the full extent of the layer. So these are simple things that you must know. Then yeah, we have created one layer. Now let us create other layers pertaining to other pollutants. So I will go here, the main layer. Now it is still filtered, so again I click on filter. Now I will remove this filter. Then I will get back my original layer, and now I will write the expression again, pollutant equal to PM10, and then OK. Now you see there are 496 stations. Earlier it was 490 stations. Now right click, same procedure, so I will be quick. Select all, right click the layer, export, save selected features as, format geo package. You select the same file, same geo package file, and now you give a different name to the layer, PM10, and CRS is EPSG 4326. Then click on OK. Now this filtering, this process you can also do from the attribute table. We will also see that. So suppose now I want to create a layer of sulfur dioxide observations. Now open the attribute table, and then here, as we have seen, if you click on the column header, it will be sorted like ascending or descending. You can select the first record, and then the sulfur dioxide records are till number 481. So 481 records are there. Press shift button on your keyboard and then click on 481 row. So these are selected. Now again, in this way you can select from the whole. Now again you go back, right click, export, save. Now I select, now exports, you have to click save selected features as. Now even if you click on save features as, it will give you the same dialog. Only thing is this box will not be checked. If you check this, then only selected features will be saved. Otherwise, again PM2.5, PM10, all those will come here. Now you save it in the same geo package and give the name SO2, layer name SO2, and then click OK. Now you can check, right click and then click on show feature count 481, PM10 feature count 496, 490 for PM2.5. Now there is a shortcut of what we have done. So let us again open attribute table. Now there is this button is for deselection. Deselect all features from the layer. You can filter the features from the attribute table by writing an expression here, like select. This selection section has one button, one tool, one icon. You can see epsilon. This you will find many places. Epsilon means expression. Select features using an expression. You click on that, you will find this dialog box. Now we are dealing with fields and values, so go to this fields and values, open this GP, and then here you will find all the fields. Again you select this and double click this, where the expression will be written over here. Pollutant is equal to, say we want nitrogen dioxide. Now you can, if you want to see what are all the values, unique values of that field, you can click on this all unique. You can even type it, but typing many a times you have to again put it in quotation. If it is case sensitive, suppose you make a mistake of capital and small letter, it will not be able to filter, or it will not be able to run this expression. So what you can do is click on all unique, say nitrogen dioxide, you double click it, and then the expression will come. Now once the expression will come, you will as long as the expression is not complete, you will have this expression is invalid warning. Once it is valid, that will be removed. So you will run this. Now you can click on this select features. So then it will select only those features whose value of pollutant is equal to NO2. So click on select features, then close. Now check whether it has been selected or not. You can see, yeah. So all NO2 features are selected. Now again go, right click, export, save selected features as, same geo package, and give the layer name as NO2, then click OK. The feature count, right click, show feature count, it is 496. I think 4 parameters we have done, and I will quickly do the remaining by filtering. Pollutant is equal to all carbon monoxide. OK. Right click, open attribute table, select all, right click, export, save selected features as, give the name layer CO, OK. Then again go to filter, remove this filter, pollutant, remove this filter and save it. After removal you have to click OK. Then filter pollutant is equal to all ammonia. OK. Right click, open attribute table, select all, minimize, right click, export, save selected features as, you give the geo package, layer, NH3. OK. Yeah, you can see the count. The total count should be 3361. There is one more. So we have 1, 2, 3, 4, 5, 6. One more. Ozone is remaining. Right click, filter, I think I have to first click on OK. OK. Right click, filter, pollutant is equal to all ozone. OK. Right click, open attribute table, select all. Oh, export, save selected features as, give the same geo package name, and then O3, save. Feature count, and you sum up all this. You should get 3361. So we have created a geo package which is a database format. Now suppose I want to remove all these, say I will remove, let us try to add the geo package. You have seen how to add delimited layer. Now suppose if you want to add geo package, I want to just show how it can be. You have to go to the same data, open data source manager here, or go to layer, add layer, and click on add geo package option here. Let us go here itself, data source manager. On the left side there are these tabs. Yes, geo package. So how to make a connection to the database? Geo package is a database based format. So new, you have to make a connection, new, and go to the location where your geo package file is. Then click on open, and you have to click on connect. Then a connection is made, and then what are the constituent layers? These are the individual constituent layers of this geo package. Each layer itself can be saved as a separate shape file, but here we have saved as a geo package layer. Now which one you want to add? You can add all these 7. Click on add, close, then they will be added to your layers panel. And if you open the attribute table of each of these layers, you will find only the values pertaining to that particular pollutant. So in this way you can manipulate the attribute table, and you can create a geo package. I just wanted to show how we can create a geo package. We have also seen identify tool. Now we will see how we can check the statistics, like how we have seen every layer has this structure of individual layer, every station, and then it has its latitude and longitude and the pollutant name, minimum, maximum, and average pollution. Suppose you are envisaging to see a single vector layer with stations and then the value of average pollutant, all the 7 pollutant values as individual columns. In Excel, you know how to make use of pivot table. We will do the same thing, and then we will try to create a new vector layer. Now let us see how to go about it. Yeah, before going to that part, let us say let us play around with one of these layers, say PM 2.5. I will remove the other layers by selecting and then right clicking and removing. In QGIS you will always have more than one way of doing the same thing. Like you can remove the layers from here also, remove layer, and also you can do that by right click. And now you have PM 2.5 layer, which is part of a geo package which you have created, which is a subset of the larger data which we had downloaded, which has 490 features. Now if you open the attribute table, and if I check the pollutant values, there are many no data values, right? There are many no data value. How many are there? 29 no data values are there, not available due to any reason. One way is you try to fill the data. If you have a time series of data, that you do it. But anyway, we are not going into data analysis part. We are trying to just see how spatial data can be created and visualized. Now what we can do is we can delete these 29 features which has no value for just for visualization purpose. So I will select 1 to 29 after sorting them out. Control shift button, and then press this. Now how to edit any layer, whether in the map or in the attribute table, you have to go to this toggle editing mode. A pencil symbol will be there here, and the same pencil symbol you will find here. You have to select the layer and go to toggle editing, and then select individual features, and you can delete. Here also we can do it much better in the attribute table. So you go to this toggle editing mode, and then you can delete this selected features. Delete 29 features, confirm, right? So before deleting, you may have observed only 29 features when they have selected, only those 29 yellow colored were selected, because these attribute table as well as the map layer are linked, as we said. And now go back to the attribute table. Now that we have deleted, you can save it by, again you click on this toggle editing mode, come out of this, and then you want to save the changes. Yes, save. Now you have all no data values are removed. So you can see the feature count is how much? 461 after removing 29. Now let us see, we can change the visualization. Go to right click. Now we will be seeing some basic functionalities of GIS and QGIS, and everything cannot be covered in one or two sessions. So we will be covering bits and pieces here, and you will continue to learn these things in the coming sessions. Let us see. You right click the layer, then this properties, and click on properties, and then go to this symbology, which is basically how you can change the visualization part. Labeling is where you want to display the labels, and there are other things. Let us check the symbology. Suppose if I want to display graduated values, but I am only getting latitude and longitude, I am not getting other fields. What is the reason? Actually, I wanted to show the visualization in such a way that stations having high PM 2.5 values are shown differently. So for that we need to go for graduated display. But here I am not getting the pollutant value, because what I have found is, if you go to the attribute table, no, not attribute table, if actually if I even check this categorized, and if I check the values, you see 1 2 3 in the prefix means it is an integer 64, and here it is decimal, right? Latitude and longitude, real number, whereas others are strings. These are strings. Even the pollutant values are stored as string in this attribute, in this column, in this field. So first we have to convert it into an integer or real number, and then we can do the display. So for that, what we can do, so better we have got a very good data set where we are learning all these tiny bits of functionalities in QGIS. Say open the attribute table, then this is the average pollutant, right? This is minimum, maximum, and average. And there are many things which are not useful here, like date is not useful. I am saving, I can save the layer itself, date can be there. This is so again, if you want to make any change, you go to this toggle editing mode, and then some fields are activated, some buttons are activated to create a new field, delete an existing field. Suppose I want to delete some field, you can click the delete field and then say I will delete the last update field, which has the date. Okay, you can retain it if you have information from different dates, but here just I wanted to show. So you can click, so it has gone. Suppose if I want to create a new field, I can create a new field. Now I want to create a new field which has integer values of average value, average pollutant value. So I can name it as the average PM 2.5 value, or I can say PM 2.5 AVG underscore AVG. It is an integer, 32-bit or 62. The value will be, you can save it as 32-bit, and then click on OK. So a new field has been created and we have to populate this field. We can do this by converting this string to integer. So you can make use of this field calculator, open field calculator, and here you can create new fields here, or you can update the existing fields. We have to go for this update existing field, check this box, and then select PM 2.5 average. We have to fill this. What we want to what we have to fill with, we have to find a function which converts string to integer. So here you can search, there will be a function toInt, yes, toInt conversion. So what it does, it converts a string to a integer number. If it cannot be converted, it will be given as invalid. So anyway, we can use this function, double click it. So expression, you have to write it here, and what you want to convert, you have to convert the field value. Which field? Pollutant 3. So that you will find under fields and values. Yeah, fields and values, pollutant 3, and you close the parenthesis. You see the expression is still invalid. You close it. So now it is valid, and then you click on apply. Okay, now you see the same value will be there, but this is a string, this is a integer. Now I can delete these pollutant 1, 2, 3. I will only keep average pollutant value, and then I will come out and save changes by, so I have a new attribute table which has PM 2.5 average, which is an integer. Now let us explore visualization. Where my layer has gone, you can right click and click to zoom to layer. Okay, in symbolization, in symbology, we have made some changes. Yeah, graduate, we have selected graduated. If you click on single symbol, it will come. So now zoom to your layer, right click, go to properties, and go to symbology tab. A shortcut, as I said, there are, for everything there will be multiple ways of doing. So you can check this open styling panel, and also for that also there is a shortcut F7 button. The advantage of this open the styling panel is it will not open in a new window, it will be docked, like it will open here itself. You can see the changes that are happening simultaneously. So here you can go to this paintbrush symbol, symbology. Instead of single symbol, we will go for graduated. Now which value we want to make use? PM 2.5. Now it has come because it is an integer. PM 2.5 average. Now which color ramp you want? So we can make use of this color ramp. There are many examples. If you right click, there will be many examples of color ramps. So suppose if we take this turbo, where low PM 2.5 values will be in blue, median in varying colors of green, yellow, orange, and high PM 2.5 values in this range will be in red. So yeah, now you come here and click on classify. Actually the number of classes by default it has come 5. You can increase those classes. So what it has done is by how it does this classification, how it creates these classes 3 to 29, 29 to 44, etc. How it creates is it will keep equal number of stations in each class interval. But if we go for this equal count mode, suppose you go for equal interval and then click the number of classes. Now I think the values are ranging from about single digit to 200 or 300. Maybe Delhi during this period it will be having very high. Otherwise also Delhi normally has high PM 2.5 values. So the values may be up to 500. So 0 to 500 we can have, say, classes of 100, or even we can take 50. Then in that case we need to go for 12 classes, which will be very high. Classify. So you can see the changes are happening simultaneously. So dark blue, now let me so you can check, dark blue circles are those which are having low PM 2.5 values. Eastern, northeastern, some parts of western India and southern India. And those metropolitan cities like Chennai, you have somewhat high PM 2.5. Similarly, if you go to northern India, you have now suppose yeah, you can even see the categorization. Green median values here, and high values dark red, which you will find in NCR. And if you want to check the values again, you can go to this identify features and click the any station. So this is Delhi Okla. The value is 394. I think I have selected more than one. You click one. Yeah, this is Major Dhyan Chand National Stadium, 368. Now if I go to somewhere here, blue, dark blue, this is from Barakpur, West Bengal. Value is 26. There must be single digit values also. 22 in Assam's Shivsagar. Right click, zoom to layer. Let me check for some hilly yeah, this one 5. The value is 5. Gangtok, Sikkim Gangtok. The value is 5, single digit. So you can even add a base layer that we will be coming further, but for now I will just show. You may not otherwise let me show it afterwards, because we have to install a plugin of quick map services. Even if you don't have it, we can without plugin also we can add a base map of OpenStreetMap. How to do that I will demonstrate. So you have this layers panel. Right click here where there is no tool and go to panels and check this browser panel. That you can also do the same thing by going to view panels and checking the browser panel. And in the browser panel, if you scroll down, there is one XYZ tiles. You click on this XYZ tiles, there is one OpenStreetMap. Now in the last session in the OpenStreetMap, we learned that OpenStreetMap is a crowdsourced data. They have base maps also. Then double click it. Then the OpenStreetMap will be added. Base map will be added. Now it has come on the top of your PM 2.5 layer, so nothing is visible here. Ideally you should know how to keep your layers in a layer panel. The point layers should come on the top, then the line layers, and then the polygon layers, and then if there is any raster. Now this OpenStreetMap is something like an image. You have to drag it down. You can drag it down by using your mouse. Now you have PM 2. The 5 layer on the top. Now you can check these. So you can zoom to any location. So this is NCR region with high concentration of high PM 2.5. Bombay is relatively better, but even there are some median, not median, but less than median only. Then similarly we can check. Um, Zoom to the layer again. So if I zoom OpenStreetMap to the layer, it will show the whole extent. I have to zoom to layer by selecting PM 2.5. So you can see the context, background context, where that particular station is located, right? You can even label the station by going to properties, go to labels, and then instead of no labels, you can select single label, and which label you want to display. Country will be same, city. Station you can display definitely, but station is local name. Maybe city you can display, city, and you can change the font, all those things. You see which font you want to display in, whether it should be bold or regular or italic, size of the label. There are n number of options, color of the label, font, you will get so many fonts. So I am keeping default. Maybe I will take bold because I have a background map, it should be visible. So size, say instead of 10 I will go to 12, and then I will click on apply. OK. So you see my cities names are displayed. Now you have multiple cities names, because each station has unique identity here. So within a city there may be multiple stations also, they are also being displayed. Okay, so maybe that is not the correct option for labeling, but just we wanted to have a locational context. So again, I don't require this browser panel. I will close this. You can go to this shortcut. Instead of going to right click, properties and symbology, you can go to this shortcut of open the layer styling panel, and in the labeling part, in the single symbol, you can display the maybe the value of pollutant itself or name of the station. But you see it is very clumsy, like the appearance is not good. You can change the font, and also you can change the way the labels are placed by going to this placement, and then how you want to set the placement of each label, whether you want to have any background. So you can change the visualization, like you want to have, yeah, draw the text buffer of what color. So there are so many options. I'm not going into them. How if you want, if you don't want to show them horizontally, but say you want to split up, like you see each of the layer, name has, station name has the location, then the city and pollution control board name. Suppose you want to show them in 2 lines instead of 1 line, because it is not looking good in the display. So in that case, what can be done is formatting. You have to separate these wrap on character, maybe space character is recognized, yes. So here wrap on character, you see each name of the station, either you can wrap on comma or space. So let me do it by comma. So you see after campus there was a comma, so you have 2 lines, Barakpur. Similarly, station name and city name are pollution control board name. So this is a better visualization. and I can still change many I can make a buffer around it. I can make a beautiful can beautify it by with so many options that are available here. Anyway, that's not for our purpose. So let us come back. I will remove this background. So from this you know how to label, how to add a base map without having any plugin. In the coming classes, we will see a plugin of quick map services for adding different kinds of base maps. I will also remove the display of labels. Yeah, so that's about visualization part. Now let us go to that pivot table part. For that, I need to get the bigger layer, not this PM 2.5 layer. I will remove this. Now I will add my vector layer that I had originally created from the delimited text data. To add my vector data, I can go to Open Data Source Manager, go to Vector tab, and here I can go to where I had saved my shapefile .shp, open, add, close. Now you can check the number of features, 3361. Attribute table, it has all the data that we had from the original downloaded file, delimited text data. Now I want to change the structure of this. Now before that, we can check the how many unique stations are there, because you have seen each of the parameter has different number of features, because different stations are measuring different number of parameters. How many unique stations are there? You can get information from, say, there is one, right click here and there is one panel of statistics. Yes, statistics panel. You check this box, a new panel has come here, right, left side, and there is only one layer which is here. So if they have multiple layers added, then you have to select, otherwise by default it will come air quality data, right? And then you select any of the field. You select station field. So you have total count 3361. Count, distinct count is 507. That means you have 507 stations in your delimited text layer in the attribute table. Now we will try to create a new table with each station 507 entries, and then in the columns we will have the value of the pollutants, average values of the pollutants. So for that we will install one plugin, useful plugin, group stats plugin. The same thing you can do by opening your CSV file in an Excel and then make use of pivot table. But here we want to do it in GIS. So for that you need to install one plugin. So plugins, we had just touched upon it during the introduction, that QGIS has a plugin architecture where you can extend the basic functionalities of QGIS by developer written applications or plugins for specific purposes. Like, so there is one plugin. If you open this plugins and then go to manage and install plugins, you will get, and go to all tab, then you will find there are about 2200 plus plugins are available. If you go to installed plugins, anyway we have a session on plugins, so I am not going into details of this. So let me come to the plugin which we are looking for, which is group stats. Search for that and then click on here. Then what is this plugin? It gives statistics and analysis for vector layers data. Rating 236 votes, so many downloads. Who created it? A I think a user, a developer, which was later migrated. Earlier it was for QGIS 2, it was later migrated to anyway. So you can install the plugin. Now remember, at the time of installation of plugin, you need to be connected to internet. So check your network connection and then click on install plugin. It will not take much time, it will take few seconds. Like now it is installed. Once it is installed, you can check that under under installed, and you make sure that this box is checked. Then close. Now you can make use of the plugin. I will cross this statistics panel. I will go to vector. Under vector, you will have a new group stats option which has just been added as we have downloaded group stats plugin, and then click on group stats. You will also find that a new icon was created in this toolbar, what is the toolbar? Plugins toolbar. Either you can click here or you can go to vector, group stats and group stats. Anyway, both ways you will open the same window. And here our active layer is air quality data, so we have the layer. And here, just as in case of pivot table, we have to add what columns you want to have, what rows you need to have, and what values you want to populate. So what we can do is we want to create a new vector layer. So first you have to create a CSV in the structure that we want. So in the rows you should have the station. So here you cannot do by double click, you have to drag and drop. So you see you have the station, you drag and put it in this box of rows, then you will have this, right? And in the columns you want to have average pollutant. No, in the columns you need to have the pollutant name. So you drag and drop here, and which values you want to have is average pollutant. You can drag and drop the value here, and then you can also check this use null values, because NA is also values are also there, and how to make use of this value. So in the original, if you open this attribute table, so every station has only one value for that particular pollutant, average pollutant. So whether you take max or mean or minimum, it doesn't matter. So I will take max. I will take max and drag here. So once you have your columns, rows and value as this, and also you may want to have you need to have latitude and longitude somewhere, but first let us create the table first. Now this calculate button will be activated, so you click on calculate. You can enlarge this. So yes, so you have how many entries? 509, excluding 1 and 2, 507. So there were 507 unique stations. So station name, and then these are the pollutant names, and each column has the average value of that pollutant. So for this station, it is measuring only 6 pollutants. That is why there are 6 values. Ammonia it is not measuring, there is no data. Some stations are measuring all the 5. See this Delhi station, PM 2.5, PM 5, 10, they are very high. So now you got a structure of what you want. So, but you also want to have latitude and longitude and other columns that you want to add. So in the columns you can also have maybe I am doing it wrong, but we'll see and we will correct it. It is so something went wrong. I will remove this, bring it to rows. I will again bring it to longitude, latitude, click on calculate. Yes, now I think we have got station, its latitude and longitude, and then the average values of all 7 pollutants. Also you may want to add other things like state, city, country. Last update I am not adding. Yeah, so I will click on again on calculate. Yes, so you have got this layer. So data you can copy, or you can even save to a CSV file, but sometimes copying or save, we will do both of things. We will copy to clip all data and then we save all to CSV file, and in the solution you create one new file, give a proper name, air quality say modified, then save it. Also, not to lose the data, you copy it and we will paste it in spreadsheet. Let us check how this CSV file is looking like. Yeah, so now the values are colon separated or what? Now instead of doing all this thing, what we do is, let us open a new spreadsheet and paste whatever we have copied, and then we will work upon the column headers and these. Yeah, so I can put my latitude here, state, city, latitude, longitude. I will remove this row. Yeah, so you have this I will remove this underscore. You have a new file. I will save it, save as CSV comma delimited file. In the same folder, replace it, save. So you have this CSV file ready with you. So wherever there is no value means the instrument is not measuring the value, and NA means not available data. Maybe data was not received at the point of download, maybe. So anyway, that we are not getting into a data filling analysis part. Now we want to convert this into a new vector layer. So what has where we have only 507 features unique for each station, and then the values are all values are stored in the pollutant average values are stored in the same feature. Now you know what to do. Now we will go fast. You can close this pivot. So yeah, one more thing is you can always save your QGIS project along with the layers which are added here by going to project tab and then save as. So earlier we had added that we have created that PM 2.5 along with base map of OpenStreetMap. We have given visualization, color visualization. You can save the project as it is. Sometimes you can also have the option of saving the styles, what color visual style you have, what symbology you have. So by keeping a style file, so you can say if you save a QGIS project, it will be saved along with all the layers. All the layers should be in the same folder where you are saving the project. Anyway, that is a better practice. So whenever you open the project directly, it will open along with and it will load all the layers, but layers must be accessible. That means they must be in the same folder. You should not change the folder of the individual layers. So you can save it, but here anyway we have closed all those things in. So what I will do is remove the layer. Now I will add again my delimited text, new delimited text data, open data source manager, delimited text, and browse to my air quality modified, open, then make sure that you are given X field longitude, Y field latitude, and then EPSG 4326, custom delimit, it is comma separated value. After making sure you also check the columns, I think they are okay. Now you click on add, close. Layer will appear same, but if you see the attribute table, you have changed the structure where you have 507 values pertaining to each station. Oh, here the name of pollutant, it has come as pollutant, but it should be station name. I have to, you can change it here. You can change it. So what you can do is you can right click, export, save features as a new shapefile maybe, and go to solution folder, and then you save it as air quality modified. You could have saved also as a geo package, but there is only one file, so I am saving it as a shapefile, air quality modified. Save. Okay. So this is text data. I will remove it. This is your vector layer. Open the attribute table and edit. And I think you have, for changing the column name, it can be done. The thing is you have to see organize columns. Okay. You can change the I have checked that we can change the column headers by going to the Fields tab. Right click your layer, go to Properties, and here you have Fields tab. And then go to Editing mode here and click on your field name. Double click and change the field name, and then save it by clicking here, and then come out of toggle editing. Oh, station, apply, come out. Okay, now you can see that it has changed. Now you can reorder this thing. um, that is fine. Now we will lastly do one more thing. We will learn one more thing. You have in this attribute table name of the station, name of the city, name of the state, name of the country we have removed, date also we have removed. Suppose you want to add a new column, new field with name of the district. Now this is a point layer, point vector layer, where every feature is a point. Now if you have a polygon layer of districts, you can overlay this point layer or on that polygon layer and check where this particular point is located in which polygon, which district polygon, and then get the district name and then add a new column with the name of the district. This can be done. There are tools which are available. This is known as joining of attribute tables. There are many ways of joining attribute tables. So that we will do, but for that we need to first collect the district administrative polygon layer. It can be obtained from the Survey of India online maps portal that we had seen in the open source data that we had seen, but we will get it from India Varis website. We will download the district polygon and then do this joining of attributes. So what we will do is we go to India Varis portal quickly, and last session we have explained, we have shown that there is a data download section from where you can download time series data as well as the geospatial data. So you click on geospatial data, you click on administrative boundary, then district headquarter, census, international, state boundary, and district boundary. So this district boundary dataset maps 733 district boundaries of India. It is prepared by Survey of India. The same file which is available, it is also given here. Now we will download it as a shapefile. Now click on this shapefile. State the purpose, academician, say, give your name and email ID, and click on submit. Then it will start downloading your layer. It will be downloaded as web WFS service. What is WFS? So it is getting downloaded. So meanwhile you can check for WFS service in GIS what it means. A WFS or web feature service is a web service that provides direct access to geographic features, including their geometry and attributes. One thing is WMS, web map service, where you will only get image, and WFS, along with the image you also get the attributes. So here we have downloading, we have already downloaded it from the WFS server. Say let us extract, go to downloads and right click, extract. So this is the district shapefile. Let me take it to my exercise folder and I will paste it here. Okay, now you know what to do. You will have how to add any layer. Go to Open Data Source Manager, go to Vector, and then here you browse where your file is located. Now another tip here, the use of browser panel. Now suppose you are keeping all your input data or all geospatial layers in one folder. You can mark a favorite of that folder. In browser panel you can browse to the folder where you are saving, say under F, drive, some folder, select some folder, and then you right click and click on remove favorite or add favorite. Say for this, so you can add a directory to as favorite. So what happens is you can quickly access your resources easily instead of browsing every time. So anyway, so let me go to add vector, right the browse my data set, which is in exercise data NWIC district.shp, op and add, close. Now you know that it has to be put it below the point layers. Now visualization, all those things I am not doing, so I just want to quickly show Now I want to show category visualization. You see, right click, properties, go to symbology. Now it is single symbol, simple color. You can change the color from here, whatever color you want to see, RGB combination. There is one option of transparent fill. Apply. You can see. Yeah. Anyway, let us use it this. Let us do from here. Yes, so that you can see simultaneously. Another is you can go to again graduated if you have some values, but here I don't think there are any values. Maybe you can do it area wise, larger district in one color, smaller districts in another color. Then categorized, you can give a colorful look by each individual district has a unique name, so you can take the name of district value and then click on classify. So you see every district has a different color. 733 values will be there. So in this way you can do the symbology or visualization part, but our purpose is not that. So you add your let me come back. It is distracting the colorful symbols. So let me go to single symbol and let me do the transparent fill. Apply. OK, and on the top of it you have your stations, right? So now what we need to do is we need to join attributes by location. Before that, both these layers should be in the same projection. Now let us check your air quality. How do you find the projection? You go to what if these layers are not in the same projection? They will not. It doesn't matter much, but always whenever you are doing any geospatial analysis, you have to reproject all layers into one projection system. Now we have learnt about this right side lowermost corner EPSG 4326, that is project coordinate system. Generally it will be GCS, or if you are adding the first layer, whichever layer you are adding to QGIS after opening a new project, this will pick up the first layer's coordinate reference system. It may be projected coordinate reference system also as the project, the overall QGIS project CRS. And on the fly, whatever other layers are added, it will be visually, it will be shown in this projection only. So if you check this district NWIC projection properties, go to information, you will find the CRS in the information. It is WGS 1984, datum is same, but it is Lambert conformal conic. It is a conical projection. So it is not global coordinate system, it is a projected coordinate system, which is well suited for India. India is not in equatorial region nor at polar region. For equatorial region, cylindrical projections are better. For polar regions, azimuthal projections are better. In intermediate, these conical projections are fine. So this LCC, again LCC, we have different EPSG codes for different states. That I will come afterwards. So these are in different coordinate systems. You mean to say both are in different projections. What we can do is we can reproject this district NWIC layer. How to do that? Processing. We said that this is the heart of QGIS. I hope we talked about it in the introduction session. All these tools which are here, which we are using in between, and hundreds of other tools we will be finding in this grouped under different sections, names, headings. So if you want to reproject, you can search for reproject tool, reproject layer under vectors. So this is a vector layer, reproject layer. So you double click it, this will open. So you give your input layer, which target, what is your target CRS? EPSG 4326. Okay, and then you run. So this algorithm reprojects a vector layer. It creates a new layer with the same features as the input but with different CRS. So you run it. So once it is run, it is completed. You get this, you close it. Now a new layer is added, reprojected layer. I will cross this. Now you see this symbol indicates it is a temporary layer. Now what is a temporary layer? Whenever you have a temporary layer in your layers panel, even if you save your project, if you close the project and once you open it again, you won't retain it. So temporary layers you can create, because every time suppose your first step and last step, intermediate, there are 10-15 layers that are to be created. So instead of saving every time layer onto your disk, you can create temporary layers and you continue and you reach the final point. And once you reach the final point, then you can final layer can be saved onto your disk, and then you can close it. Otherwise you can save any temporary layer any point of the time by right click, export, and now here we will select save features as. All features we will save in the same folder. What we can do, district NWIC reprojected, save CRS, then click on OK. Now you see a new layer is created. I will remove the temporary layer by right clicking and remove. Now you can also get the information about CRS by going to properties and information. That is one way. You see it is EPSG 4326. Now both layers are in the same CRS. And another is, you take your mouse on the top of the layer, then it will give you the name of the layer, where that layer is located in, what is the type, it is a multi-polygon layer, and where it is located on your drive, and also its CRS. Yeah, here it is given CRS EPSG 4326. EPSG 4326. Here it is not displayed because LCC doesn't have one code. LCC projections, it has different codes for different states, which you can check in those websites of epsg.io, and you check Lambert conical. Or you can see another website is spatialreference.org. Here you can search for Lambert conical. Lambert conical India, LCC India. Yes, LCC India 7755. Yeah, this is the whole code which is applicable for the whole of India, but every state will also have individual codes which are defined by, see, EPSG 7756 for Andhra Pradesh, EPSG 7757 for Arunachal Pradesh, and so on. These are all our Lambert LCC projections. You can find these codes anyway. So anyway, the code is not defined in the layer. That's why it is not being displayed. Otherwise, it's LCC, it's CRS. You can check in the information tab. It is Lambert conformal conic. so it is no longer useful. I will remove it. But suppose, yeah, there is one more small tip. Suppose you want, this is, you have changed the symbology and has removed layers by filling the transparent color. Suppose you want to apply this style to this layer without again going through multiple steps. There is a simple shortcut. You check this layer, right click, then go to styles, copy style, copy all styles, or you can simply copy the symbology. Suppose you also have the labels, all those things defined, then you can copy all styles, but here we can simply copy the symbology. And now you go to the target layer, right click, go to styles, and then paste style, and then symbology. Now you see it's a transparent field. Now I will remove this original layer. I will have my air quality stations also. Now I will run the tool join attributes by location. Before that, you can even check the attribute table of the districts. So you have every district has a code, district name, state code, name in short, and then the area shape, area of that polygon, and length of that polygon. Okay, so we are more interested about which attribute, district, and we want to add it to our attribute table, a new column of district. For that, we go to processing toolbox and join attributes by location tool, which is under vector general heading. So here, which layer you have to select, join to features in air quality which intersect with our district, and which layer which columns you want from this district. Fields to add. Under fields to add, you select only, check this district, go back. Now everywhere you take your mouse, it will tell you what to do or what it does. So go back. So you want to add your district, and join type create separate feature for each matching feature. Yes, one to many. You can create a temporary layer, or you can save it to disk. Now let us run and create a temporary layer. You can see the description of this tool. This algorithm takes an input vector layer, which is your air quality layer, and creates a new vector layer that is an extended version of the input one. We want an extended version of the input one. That's why we have not selected the district here. We have selected air quality here with additional attributes in its attribute table. These additional attributes and their values are taken from a second vector layer, which is our district layer. So you run it. There is some warning, our execution is failed. This has invalid geometry. Let us check whether it has generated or not. So in the joined layer, a new temporary layer is generated. Right click and open attribute table. Yes, there is some issue with geometry. Let me remove this. Sometimes these issues are because of trivial things like you haven't saved it onto your disk. So let us see if there is any issue with our reprojection. Let us run the tool again. Toolbox, join attributes by location, intersect. Maybe the issue is with this point intersecting. Okay, say are within. District. Run. Same issue. Let us save it to disk. Intersect, district field, the joined layer, save to file, go to solution, say give some name, we can rename it afterwards if required. Joined layer, save, run. I think the issue is persisting, but you can check the attribute table. It is joining the district, but after 12 features, it is facing some issue with geometry. The error is what? Let's see why the error is coming. We will run it again. Processing toolbox, join attributes by location, input layer air quality modified, intersect, or you can keep R within, then comparing with district reprojected, and the field that is to be added is district. Run to create a temporary layer, but this is not getting executed fully because of some issue with invalid geometry in the district shapefile. Please fix the geometry or change the invalid features filtering option for this input or globally in processing settings. Whenever you face any issue with the running of any algorithm in QGIS, simply copy the error message and search. You will definitely find some or the other solution from these forums. Yeah. In attempting to perform a simple join attributes by location between two shape files, I get an error message in a different language, but the actually yeah, so this is the solution given by some user. We will also now I will remove this temporary layer. We have to make some changes in the setting. We have to go to settings, option, processing tab, and then look for invalid features filtering and change. Stop algorithm execution when a property is when a geometry is invalid. We have to change this. So let us go to settings. In case if you are also getting the same error, most likely you also go to settings, go to options, then go to processing on the left tab, processing, scroll down and you will find the processing, and under general you will find one, yes, invalid filter featuring. The current option is stop algorithm execution when the geometry is invalid. Now double click it and you will find this drop down menu. you can check this option of skip or ignore features with invalid geometries without stopping the execution of the algorithm, or this third option is do not filter. Yeah, do not filter. So invalid features will not be filtered. So click OK. Let us see after change of this setting. Do not filter. Okay. The error message or warnings is fine, no issue with that. No join attribute by location. You run this again. Air quality modified as input, intersect, and then district NWIC projected, and then what you need to add is district. Go back and then run. Hopefully it is running fully this time, as it is taking time. So what is happening is, by the default settings, whenever there is an invalid geometry happens for many reasons. Mostly in polygons this issue will be there. So now it is generated, and then the join count is also 507. Input count is also 507 stations. So it is fully implemented. Let us check our temporary layer, joined layer, open attribute. So you have the district added. You have the district added to every station. So we can right click, export, save features as, because it is a temporary layer, you have to save it somewhere. Maybe we can go to the same geo package. We will save it as a geo package. Geo package, air quality data geo package, and here what we can give the layer name is all pollutants. Also it has an additional district layer also, district field also. So click on OK. If I right click and open the attribute table, you will have the district layer. So that's all for this session. We had a lengthy session, but I think we have covered many of the basics, like zooming to layer, identifying features, filtering features, feature count, how to count the value, how to make use of one plugin, group stats plugin, how to create a geo package, how to add a geo package, how to download a shapefile from IndiaVaris portal, and how to do this join attribute by location. Most of the time we come across text data, delimited text data, and if it has geometric coordinates, we can convert it into vector data, and we can manipulate the attributes by using various options which are available, like selection of features, field calculator, many things, many options are there. One has to explore and see the potential use of each of these tools. So we have come to the end of this session. In the next session we will have working with vector data. Thank you very much.